Welcome to Master Mathematics in Minutes. Today's topic is about how to calculate the angle of a right angle triangle. And we'll cover a couple of examples on how to calculate angles with trigonometry. And we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, how do we calculate the angle of a right angle triangle? Consider a right angle triangle or right triangle. We can calculate the angles using trigonometric functions. Visually, we have a right angle triangle, and we'll label this angle here as theta. So the side that is opposite the 90-degree angle is called the hypotenuse, and it is also the longer side of the triangle. And this side, which is opposite the angle theta, is called the opposite side. And the side that is next to theta is called the adjacent side. So we have the sine of theta is equal to the opposite side over the hypotenuse, or O over h. And cos of theta is equal to the adjacent side over the hypotenuse side, or A over h. And the tangent of theta is equal to the opposite side over the adjacent side, or O over A. So the hint is to remember the words so, ca, and toi. So S stands for sine, and O is the opposite side, and H is the hypotenuse side. And C stands for cos, and A is the adjacent side, and H is the hypotenuse, and so on. Let's take a look at a couple of examples now. In the first example, we'll also consider the following right angle triangle, and we'll also calculate the angle theta. So, we have this side, which is the opposite side to theta, as 4 centimeters. And we're also given this side, which is opposite the 90-degree angle, and that is the hypotenuse. So the function that relates the opposite side, O, and the hypotenuse side, h, will be the sine function. And so we'll choose the sine function in this case. So the sine of theta is equal to the opposite side over the hypotenuse, or O over h. So sine of theta is equal to 4, which is the opposite side, divided by 8, which is the hypotenuse. And theta is equal to the inverse sine function of 4 over 8, and that is equal to 30 degrees. In the second example, we'll also consider the following right angle triangle, and we'll also calculate the angle theta. So we're given this side, which is next to theta, and that is the adjacent side of 75 centimeters. And we're also given this side of the triangle, which is opposite the 90-degree angle, and that is the hypotenuse. So the function that relates the adjacent side A and the hypotenuse side h will be the cos function. And so we'll select the cos function in this case. So with cos of theta is equal to the adjacent side over the hypotenuse, or A over h. And so cos of theta is equal to 75, which is the side, the adjacent side, over 106.07, which is the hypotenuse. And solving for theta, with theta is equal to the inverse cos function of 75 over 106.07. And that is equal to 45 degrees. In the third example, we'll also consider the following right angle triangle, and we'll also calculate the angle theta. So, this side, which is opposite theta, is called the opposite side, and this side, which is next to theta, is called the adjacent side. So the function that relates the opposite side, O, and the adjacent side, A, will be the tangent function. So we'll pick the tangent function in this case. So we have tangent of theta is equal to the opposite side over the adjacent side, or O over A. So tangent of theta is equal to 5.1, which is the opposite side, over the adjacent side, which is 10. And solving for theta, with theta is equal to the inverse tangent function of 5.1 over 10, and that is equal to 27.02 degrees. In the fourth example, we'll also consider the following right angle triangle, and we'll also calculate theta. So we're given this side, which is next to theta, and that is the adjacent side. And we're also given this side, which is opposite the 90-degree angle, and that is the hypotenuse. So the function that relates a, the adjacent side, and h, the hypotenuse side, is the cos function. And so we'll pick the cos function in this case. So if cos of theta is equals to the adjacent side over the hypotenuse, or a over h, and cos of theta is equals to 6.93, which is the adjacent side, over 8, which is the hypotenuse side. So solving for theta, with theta is equals to the inverse cos function of 6.93 over 8, and that is 29.97 degrees. To summarize, consider a right angle triangle or right triangle. We can calculate the angles using trigonometric functions. Visually, with a right angle triangle or right triangle. And we'll label this angle here as theta. So the side that is opposite the 90-degree angle is called the hypotenuse, and it is also the longer side. So the side that is opposite the angle theta is called the opposite side. And the side that is next to theta is called the adjacent side. So with the sine of theta is equals to the opposite side over the hypotenuse, or O over h. And the cos of theta is equals to the adjacent side over the hypotenuse, or A over h. And tangent of theta is equals to the opposite side over the adjacent side, or O over A. So the hint is to remember the words so, ca, and toi. So S stands for the sine function, O and H stands for the opposite side and the hypotenuse side, respectively. So ca is where C stands for the cos function, and A and H stands for the adjacent and hypotenuse side, respectively. And so on. Thank you very much for watching. This is Master Mathematics in Minutes.